Hey guys, it's East Village. Welcome to episode 2 of my RLBot tutorial. Today I'll be explaining a bit more about how the framework works, and then we'll be looking at some vectors. Last time I was a bit quick about explaining this thing, so this time I'll go a bit more in depth. The bot manager here is what starts our bot and makes sure that it receives the game-tick packets and also shuts down the bot correctly. To communicate with the Python part, we start up a socket and communicate through a port. We will receive this port through the arguments, and in case we don't, we will just use a default port. This is relevant for development where the bot doesn't auto start. Once we have the port, we can start the Python interface, and this is the part that talks to the Python part. It is also in here that we define which bot is spawned by this process. We can just go in here by pressing Ctrl B, and you can see that it spawns goblins. Lastly, we start the Python interface in a new thread, and the rest of this file is actually just GUI stuff. You can take a look at it if you want, but it's just the thing that starts up when I run it here. This part. It tells us which bots are currently running. Since the port is hard-coded, we can actually hit port conflicts. So I recommend that you find a unique port for your bot. Make it some rare port up in the high numbers. I'm going to choose 7844. And make sure that once you have a port, you also go into the goblin.py here in the Python part and put the port in here. This is the port that is sent to the Java part when our bot is auto started. I keep mentioning this auto starting, but what does it actually mean? Well, once we have a bot we want to share with other people, we can go over here in the Gradle tab and run this dist zip. This will create a zip that contains our bots, and this one you can send to other people and they can run tournaments with it, so on. If we look what's in here, you can see we have our Python part again, which contains all the files that are also over here, and then there's the Java part, and in here there's a bat file, which is the one that starts up our bot or the Java side. You can also recognize that this path is the one that we wrote down in our goblin config here. If we weren't doing development, the RLBot framework would start the Python script, which then lets the framework know that it should run this bat to start the rest of the bot. I am now in the goblin class, and I want to explain this a bit in depth as well. Currently this is our logic for our bot. It's very simple, and this is what we're going to replace over time. The method takes a data packet, which is our own wrapper for the game-tick packet, which we get directly from the game, or from the RLBot framework to be exact. The game-tick packet contains all the raw data that is dynamic from frame to frame, and in our data packet we are going to pick out the data that we want and maybe do some analysis. Currently what we do is we find the position of the ball and the position of the car and then the direction of the car. And to create the direction of the car we actually have something called a car orientation. If I just Ctrl B here again, we can see this is all the car data, and if I press Ctrl B here again, we get to this class, which is the car orientation. Here you can see that we did some math to translate the pitch, yaw and roll that we got from the game-tick packet to create 3 vectors. One that points forward, one that points to the right, and one that points upwards. Actually we just calculate the forward and up, and then we use the cross product to find the last one. Back in process input, the next thing we do is we find the difference between these two positions, so we now have a vector from the car to the ball, and then we'll calculate what the angle is between those. and here we use this small little function that makes sure that the number is always between a positive pi and a negative pi, which makes it easy to translate back into which way are we going to steer, which is exactly the next thing we're going to do. If the number is positive, then we go left, otherwise we'll go right. If we just skip the debug drawing here and the quick chat here, you can see that the last thing we do is that we send the controller output back to the framework, and we do it with a steer of -1 or +1 based on which direction we're going, and with a throttle of 1 to go forward. To show you the drawing of debug lines and the quick chat, I'll just start up the game. So we'll go back to the project folder and run the run.py file. We also have to make sure to start our bot. And you can see here that our goblin renders a line from itself to the ball, and then it says left or right depending on which side it is going. If we look in the code, we can see in this method that is exactly what is happening here. First we get the renderer for our bot, then we draw a line, a light gray line from my position to the ball position, then we render our nose vector as either blue or red depending on if we're going left or right, and then we draw it as a 3D string as well, which is the text here on the bot, left, right, left, right, left, right. And lastly, we're also drawing our ball prediction, so the framework can actually predict where the ball is going for us, which is going to be useful later. And we can easily draw this with this helper function, and you can see it here in the background how the ball is going to bounce. If we look at the quick chat, we can see that if the ball positions the set is greater than 300, that means if the ball is in the air, we're going to send a quick chat message that is nice one. And this boolean here is, if I press Ctrl P, I can see the arguments. That is whether or not it's for the team. Okay. And you can see here that the ball is now in the air, and our goblin wrote nice one in the quick chat. Now our quick chat is just rendering. Before we got the API, we were able to print the quick chat just like normal chat in the game. But the Psyonix API isn't really there yet, so for now we're just rendering it. This might look different in the future and will actually look like quick chat. Let us try changing some things here. Let's make our bot go backwards. We can do this by just changing the throttle to -1. The changes haven't been applied yet because the running bot haven't been updated. All we have to do is just rerunning our project. And now if we go back into the game, we should see that it's now going backwards. So that's the typical development flow here. We change some things, then we rerun the code. We could also change the rendering, so instead of drawing a light gray line to the ball, we could draw another color, like a bright blue. And then we rerun again, stop and rerun. And you can now see the line to the ball is blue. I have now loaded up the RLBot wiki, so that's the RLBot/RLBot repository. In this wiki we can find all the general stuff, and I just want to show you the coordinate system of Rocket League. So here in the useful game values, we got this really great picture with the dimensions of the arena. And we can see that the arena is 10,000 units long and about 8,000 units wide. But what you should note is that in this coordinate system, x is to the left and y is to the north, and then z is upwards. That's typically not how you make coordinate systems. The x is usually to the right. So if you're used to doing linear algebra and such, keep this in mind. If you aren't comfortable with vectors yet, just think of them as points or as directions. So the vector 1000, 1000 would be somewhere around here. But you can also think of it as the direction from the center to my mouse. So a direction towards the northwest. But it also has a length or a magnitude, as we call it, which is then the distance from the center to my mouse. All the positions in the GameTick packet will be vectors. So the car's position, the ball's position, those will be vectors. But similarly, the velocities will also be vectors. So if our car is moving towards the orange side, the velocity would be a vector that points somewhere towards the north here, towards positive y. And by adding the velocity to our car's position, we can kind of predict where we're going. So if we're here and we know we're going towards positive y, then we're probably soon going to be here. But honestly, if you don't know what vectors are, I would recommend that you find a specific YouTube video by 3 Blue 1 Brown. This one right here. Vectors. This one. Now let's start changing things. The very first thing I want to change is I want to make some changes to our vectors. First of all, we don't actually need a vector 2. A vector 2 is the same as a vector 3, except the z components is 0. I also found the name vector 3 a bit wordy. I'm going to call it just Vec3, because we're going to write a lot of vectors, so if we can save a few characters there, that's great. The same goes for all these methods. There's a few of them I think is a bit wordy, so that's also a thing I'm going to change. Also notice that we can create a vector from the vector 3 that comes directly from RLBot. But then look at this negative sign here. Let's place a negative sign here to reverse the x in here. So in other words, the example bot is actually trying to flip this one over, so we have a right-handed coordinate system like we're used to. The problem with this is that the Java example bot is the only bot that does this, which means whenever you're talking to other people about your code, or when you're looking at example code from somewhere on the wiki, it might not work because your coordinate system is opposite theirs. So what we're going to do is we're going to live with this coordinate system. I'm going to accept it and remove this negative sign as well. Okay, I'll go ahead and make these changes now. Okay, I'm now done changing the Vec3 class. So I'll just go ahead and select the Vec2. Oh, and that creates an error here. This one now creates a Vec3, but the set component is 0. Okay, there we go. So first thing first, I added the x, y, and z component here, even though they also derive from our vector class here from RLBot. But it turns out in here it's all floats, and our math later will always be in doubles. So to avoid converting back and forth all the time, I made these doubles. But the float version still exists in here if we're working with the Vec3 class from RLBot. And now we're no longer inverting the coordinate system, so no negative sign here. There also used to be a toFlatBuffer method here, but it turns out it's already in here, so we don't need to do it again. Next up, I made these 3 methods, and these basically create a vector that is similar to the vector we have already, but with one of the components swapped out with something new. This is useful if we just want to change the x coordinate of something, but wants to keep the other 2 components. Then I renamed these methods so they were a bit shorter, so scale to magnitude is just scale to mag, and the distance is just dist, magnitude is just mag, the magnitude squared is just magnitude, SQR. I did not change the normalized method, and that's because there's already something called a norm, which is kind of similar to magnitude. So to avoid any confusion, we'll keep this as normalized. Then there's the dot product and the cross product. We'll just call these for dot and cross. But other than renaming and changing this negation of the x, I haven't actually changed anything else. Well, except I did add these 2 here. Some 2 static final vectors, which means they will just always exist. And I made these 2 up and 0 because we're going to use these 2 a lot, so let's just create them once. Now, since we changed these components to be doubles, we're going to find some errors here and there. And we also removed the Vec2, that's also something we have to fix. So first, let's just start by replacing these with Vec3s. Our Vec3 does not have this correction angle method, so instead we're going to do a little trick with the orientation and a dot product. But before we can do it, we just have to fix the orientation. So in the input and in the car orientation class, we're going to change how this one works. It's going to do exactly the same thing, but since we changed the coordinate system, all of this math down here is now wrong. I also want to rename the nose vector to just forward, and roof and right vector will be up and left. It's going to be left since we changed the coordinate system, that's why. So let me start renaming things here. So this one is forward, and yes, we also want to change the parameter name. Doesn't matter really, but let's do it. The roof is now up, and our right is now left. And let's just make sure the comment here is right. So for the math down here, I'm going to rewrite it quite a bit actually. I'm actually also just going to copy paste it in to make sure that it's correct. It's going to look something like this. Oh, that might not have worked perfectly. There we go. So forward and up, and we can now create our orientation. Up. No wait, this is forward. and this one is going to be up. So here we do the smart thing of only calculating the cosines and the sines once and then applying them all the places we need in one go. And then we return the car orientation, and we just need the forward and up because the last one we can find by doing a cross product. Now that our car orientation is fixed, we can go back into the goblin and fix how we steer. What we're going to do is we're going to create a double that is just a steer, and we're going to use a trick of the dot product. If you have two vectors that are perpendicular, the dot product of those two vectors will be 0. And if they're going in the same direction, it'll be 1, and if they go in the opposite direction, it'll be -1, assuming that both vectors has a magnitude of 1. This turns out to be super useful because if we take our left vector, so the left direction of our car, and dot it with the direction to the ball, so car to ball, and we're going to normalize it to make sure that it has a length of 1. Now the result will be 0 if we're pointing in the correct direction, and it'll be positive or negative depending on which direction we're going to turn. And I know this will be the opposite direction of the one we actually want to steer, so we'll make it negative, and then we can just plug in the steer right down here. And now it's complaining about that our steer is a double, but it expects a float, and that's because everything in the controller here needs to be a float. So this is also one of those places where we don't want to do too much conversion. So instead I'm going to make all the arguments to doubles and then just do the conversion inside the controller class. So that's the only place we have to do it, and we don't have to do it on the outside of the controller class. Okay, so I changed all the arguments to be doubles, and the clamp function here is going to make sure that the number is between -1 and +1, because that's the allowed range for all the floats here. And then we're going to cast it into a float. So now back in our goblin, we should see that error go away. And we still have this other line of code which is actually wrong, so let's delete those. We also don't need the car's forward direction, and this go left boolean is not needed anymore, as well as the debug rendering and the quick chat. Okay, now we're down to just a few lines of code, but they should do sort of the same as before. Let's try it out. No, there was a compile error. Oh, right here, you're trying to import a class that doesn't exist. I believe that's the only error. Yes, now our bot is running and we can start the match again. I'll just switch perspective here. Oh, our bot is still going backwards. That's right. Let's change that. So our throttle is just going to be positive, and let's rerun it. And look back in here. It works. Now the bot turns a bit slower than before. That's because we're using a float to decide which way to steer instead of just a double and then go max steer to one or the other side. We can make it turn a bit more by just multiplying this up. So let's try with 5 and rerun. And yeah, this looks a bit better. Let's just see it here after the kickoff. Yeah, this is better. So now we updated the vector class. And we also had to update the orientation class as a consequence. So now we are one step closer to making the bot logic. Next episode we are going to look at the data packet, and we're going to make some improvements and some cleanup in there so we are ready to make some bot logic. We're also going to have a quick look at the controller output. See ya.